In today's lesson, we will master the technique of solving complex equations by reducing them to quadratic form using substitution. You will learn how to identify hidden quadratic patterns in fractional, logarithmic, and exponential equations. This skill is vital for the IGCSE Additional Mathematics syllabus because it allows you to simplify high-level algebraic problems into manageable quadratic equations that you already know how to solve. The general principle of substitution states that if an equation can be written in the form a times the square of f of x plus b times f of x plus c equals 0, we can replace the function f of x with a single variable, usually u. Let u equal f of x. By making this substitution, we transform the original expression into a standard form quadratic equation, a u squared plus bu plus c equals 0. This is the bridge that connects complex algebra to standard quadratic methods. Once we find the values for u, we simply set them equal to our original function to find the final values for x. Let's solve the equation x to the 4/3 plus x to the 2/3 minus 12 equals 0. Step 1. Identify the substitution. Notice that x to the 4/3 is equal to the square of x to the 2/3. So, let u equal x to the 2/3. Step 2. Form and solve the quadratic. Our equation becomes u squared plus u minus 12 equals 0. Factorizing this gives u plus 4 times u minus 3 equals 0. This yields two possible values for u equals -4 or u equals 3. Step 3. Solve for x. For u equals -4, we have x to the 2/3 equals -4. Since x to the 2/3 is the square of x to the 1/3, and a square cannot be negative for real values, there is no real solution here. Now for u equals 3, x to the 2/3 equals 3. To isolate x, we raise both sides to the power of 3 over 2. X equals 3 to the 3 over 2, which is the square root of 27. Remember, when taking roots of even powers, we must consider the plus or minus sign. Thus, x equals plus or minus 3 root 3. Let's look at a logarithmic case. Solve 2 times the square of log natural 5x plus log natural 5x minus 6 equals 0. We let u equal log natural 5x. This gives us the quadratic 2u squared plus u minus 6 equals 0. Factoring results in 2u minus 3 times u plus 2 equals 0. So u is 1.5 or -2. For u equals 1.5 log natural, 5x equals 1.5. Taking the exponential of both sides, 5x equals e to the 1.5. Thus, x is approximately 0.896. Similarly, for u equals -2, log natural 5x equals -2. This means 5x equals e to the -2 power. Calculating this, x is approximately 0.027. Exponential equations often require a bit of rearrangement first. Solve 3e to the x equals 12 minus 5e to the -x. Multiply the whole equation by e to the x to remove the negative index. This gives 3 times the square of e to the x minus 12 e to the x plus 5 equals 0. Let u equal e to the x. Using the quadratic formula, we find u. U equals 12 plus or minus the square root of 84, all over 6. This simplifies to 2 plus or minus root 21 over 3. This gives decimal values 3.5275 and 0.4725. Taking the natural log of both, we get x approximately 1.26 and -0.75. Let's apply this to an equation with fractional indices. We want to solve x to the power of 4/3 plus x to the power of 2/3 minus 12 equals 0. Step 1. Identify the substitution. Notice the relationship between the powers. 4/3 is exactly double 2/3. X to the power of 4/3 equals the square of x to the power of 2/3. So we let u equal x to the power of 2/3. Step 2. Form and solve the quadratic. Substituting u into our equation gives us u squared plus u minus 12 equals 0. This factors nicely into u plus 4 times u minus 3 equals 0, which gives us two possible values, u equals -4 or u equals 3. Step 3. Solve for x. First, we check u equals -4. X to the power of 2/3 equals -4. Since x to the power of 2/3 is the same as the square of the cube root of x, and a squared real number cannot be negative, there is no real solution here. Now, we check u equals 3, x to the power of 2/3 equals 3. To isolate x, we raise both sides to the power of 3 over 2. X equals 3 to the power of 3 over 2, which is the square root of 27. Simplified, this is 3 root 3. However, since the numerator of our index was even, we must consider both positive and negative roots. So, x equals plus or minus 3 root 3. Next, we tackle a logarithmic equation. Solve. 2 times the square of the natural log of 5x plus the natural log of 5x minus 6 equals 0. Step 1. Identify the substitution. The repeating term here is the natural log of 5x. Let u equal the natural log of 5x. Step 2. Form and solve the quadratic. Our equation becomes 2u squared plus u minus 6 equals 0. Using the AC method or inspection, this factors to 2u minus 3 times u plus 2 equals 0. Setting each bracket to 0 gives u equals 1.5 or u equals -2. Step 3. Solve for x. For the first case, the natural log of 5x equals 1.5. To undo the natural log, we take the base e of both sides. X equals e to the power of 1.5 divided by 5. Calculating this gives approximately 0.896. For the second case, the natural log of 5x equals -2. 5x equals e to the power of -2. X equals e to the power of -2 divided by 5. This gives approximately 0.027. Both solutions are valid as the argument 5x remains positive. Finally, let's look at an exponential equation. 3e to the power of x equals 12 minus 5e to the power of -x. Before we can use substitution, we need to deal with that negative index. We multiply the entire equation by e to the power of x to eliminate it. Now we bring everything to one side to set it to 0, and then let u equal e to the power of x. This gives us 3u squared minus 12u plus 5 equals 0. This doesn't factorize easily, so we use the quadratic formula. U equals 12 plus or minus the square root of -12 squared minus 4 times 3 times 5, all over 2 times 3. U equals 12 plus or minus the square root of 84 over 6. Simplifying the surd, we get u equals 2 plus or minus the square root of 21 over 3, which gives us approximately u equals 3.5275, or u equals 0.4725. Since u is e to the power of x, we take the natural log of our results. X equals the natural log of 3.5275, which is approximately 1.26. And for the second value, x equals the natural log of 0.4725, which is approximately -0.75. Let's solve a typical IGCSE past paper style question. Find the exact values of x for which 9 to the power of x minus 10 times 3 to the power of x plus 9 equals 0. To solve this, we must first recognize that 9 is 3 squared. The square of 3 to the power of x minus 10 times 3 to the power of x plus 9 equals 0. This reveals our hidden quadratic. Let u equal 3 to the power of x. Substituting u, we get u squared minus 10u plus 9 equals 0. This factors easily. U minus 9 times u minus 1 equals 0. So u equals 9, or u equals 1. Now we substitute back to find x. For u equals 9, 3 to the power of x equals 9. Since 9 is 3 squared, x must be 2. For u equals 1, 3 to the power of x equals 1. Any non-zero number to the power of 0 is 1, so x must be 0. The exact solutions are x equals 0 and x equals 2. Let's look at where students often lose marks. First, forgetting to solve for x. Many students successfully find the values for u and stop there. Remember, the question asks for x. Always perform that final back substitution. Second, neglecting the validity of solutions. For example, if your substitution is u equals e to the power of x, and you find a negative value for u, you must reject it because e to the power of x is always positive. Similarly, you cannot take the logarithm of a negative number. Third, errors in index laws during the setup phase. When you see x to the power of 4/3, you must correctly identify it as the square of x to the power of 2/3. In the exam, clearly state your substitution. Write, let u equal. This helps the examiner follow your logic and can earn you method marks even if you make a calculation error later. Secondly, check the wording. If the question asks for exact values, do not give a decimal approximation. Leave your answer in terms of surds, fractions, or natural logs. Finally, verify your answers. If time permits, substitute your final x values back into the original equation to ensure they satisfy it. It is time to test your understanding. Pause the video now and try to solve these 3 questions. Easy. Solve x to the power of 4 minus 5x squared plus 4 equals 0. Medium. Solve 2 to the power of 2 times minus 6 times 2 to the power of x plus 8 equals 0. Hard. Solve 2x to the power of 1/2 plus 5x to the power of 1/4 minus 12 equals 0. Take your time with these. When you are ready, press play to see the full solutions. Let us go through the solutions for the homework questions. For the easy question, we have x to the power of 4 minus 5x squared plus 4 equals 0. Let u equal x squared. The equation becomes u squared minus 5u plus 4 equals 0. Factorizing, we get u minus 4 times u minus 1 equals 0. So u equals 4 or u equals 1. Substituting back, x squared equals 4 implies x equals plus or minus 2. X squared equals 1 implies x equals plus or minus 1. For the medium question, 2 to the power of 2x minus 6 times 2 to the power of x plus 8 equals 0. Let u equal 2 to the power of x. The equation becomes u squared minus 6u plus 8 equals 0. Factorizing, u minus 4 times u minus 2 equals 0. So u equals 4 or u equals 2. Substituting back, 2 to the power of x equals 4, so x equals 2. 2 to the power of x equals 2, so x equals 1. Finally, the hard question. 2x to the power of 1/2 plus 5x to the power of 1/4 minus 12 equals 0. Let u equal x to the power of 1/4. The equation becomes 2u squared plus 5u minus 12 equals 0. Factorizing gives 2u minus 3 times u plus 4 equals 0. So u equals 1.5 or u equals negative 4. Substituting back, x to the power of 1/4 equals 1.5. X equals 1.5 to the power of 4, which is 5.0625. For the second case, x to the power of 1/4 equals negative 4. Since an even root of a real number cannot be negative, there is no real solution here. The only solution is x equals 5.0625. To summarize our lesson, Substitution is a powerful tool used to simplify complex equations into a standard quadratic form of the type a u squared plus bu plus c equals 0. Always look for a term that is the square of another term in the equation, such as x to the power of 4 being the square of x squared, or e to the power of 2x being the square of e to the power of x. Once you solve for your substitution variable, you must always substitute back to find the final values for the original variable x. Finally, always check for invalid solutions, especially when dealing with even roots, logarithms, or exponential functions, as these often have restricted domains.